Hello everybody and welcome to this episode of Programming and Algorithms. In this episode we're going to look at a different kind of sort. So we've looked at bubble sort and how to optimize it. We're going to look at a different way of achieving the same thing. So if we have a list of values, how to sort them in order. It's called SelectionSort, and I think it's much easier for a person to understand this approach to sorting, although it's less natural for the computer somewhat. In terms of why it's taught in this order, bubble sort is easier to understand based on what we've done already, which is while loops and if statements and for loops and things like that. So bubble sort is a nice compact sorting algorithm, and once you understand bubble sort, selection sort is really easy to follow. So selection sort works as follows. What it says is, scan all the numbers in the array and find the smallest number, and then swap that smallest number with the first position in the array. So put it in its correct place. Scan through the array and find the second biggest number in the array. And wherever that second biggest number is, let's say it's in position 5, swap that value with whatever value is in the second position in the array. Find the third biggest number in the list, swap that into the third position, and swap whatever value is in the third position into wherever that value was found, and keep on going. So if we were to work it out as an example, we'd start off and find the smallest number in the list. It's number 16. So we want to put the number 16 in position 0. So we want to swap around 44 and 16. Let's do it. Perfect. So we've got the first value sorted now. Let's find the second value. It should be in position 1 now. It's number 18. So let's take the number 18 and swap it with the number 23 and put that in its correct position. Number 2 in the array, the third value across, 23 is the number that should be in there, so swap that with 42. Fourth value in the array is 33, and it's in position 3 already correctly, so we don't do anything there. Fifth value, position 4, it's the number 34, so we swap 44 with 34. The sixth value across, position 5, is 42, so we swap 42 with 54. Sixth value across is 44, it's in the correct position, and then eighth value is 54 and it's in the correct position. So that's the whole array sorted. So if we know, all we have to do is swap the value if it's not already in its current location. Surprisingly enough, the algorithm for this looks a lot like bubble sort, even though we're doing something completely different. In terms of figuring out how to do the swapping, I'd say a bit of code like this would do it. If we want to find out the minimum value, we'll say, and if the minimum value is not the current location, then swap whatever location the minimum value is with the current location. So that's what the code looks like. It's the swapping we just saw. Swap whatever number, let's say the minimum value is in position 4. Swap the value in position 4 with the value in position 0 if they're not the correct location, but if the minimum value 0, as it happens, is in the correct value 0 already, we just don't do a swap. So that's what our code looks like. We're using the swap function we created previously. So if we want to do it in a list, we'll go from 0 to n, let's say, but we can do increasing count as well, as we saw in the last one. So we'll go and check if the current value is the minimum value. So the first half of this really is finding out what is the minimum value in the array. So we know our minimum value is 16. So how we find that is we go from the start of the array to the end of the array, and we assume that the first value is the minimum value. If the first value is 44, let's assume that's the minimum value. Then we check the next value. Is the next value less than 44? If it is, we'll assume that value is the minimum value. We keep on going to the end of the array, and every time we encounter a value less than the current minimum value, then we assign a new found minimum value. So we pass through the array and say, find me the smallest number. So let's just go from the start to the end. When we find a value that's smaller than our current minimum, assign the value that is we've found that smaller to be the minimum value. And then we'll find that our minimum value is number 16. So here's what selection sort looks like. It's the program of selection sort. We create an array, same array as before, and then we have two loops. The outer loop is doing the actual, is going from the start to the end of the array, and the inner loop is finding the minimum value each time. So we pass the array and find the smallest value in it. Then we swap that with position 0. Then we ignore position 0 and for the rest of the array find the minimum value and swap that with position 1. From position 2 to the end of the array, we find the smallest value and swap that with position 2. Then from position 3 to the end of the array, we find the smallest value and swap that into position 3. Then from position 4 to the end of the array, we find the smallest value there. And then we swap that with position 4 and so on until we get to the end of the array. So we need 2 loops. One loop is finding the smallest value, and that's the inner loop. And then the outer loop is saying, keep doing that until we've got to all the swaps done. So it's the exact same kind of structure as bubble sort. We've got a loop inside a loop and an if statement that we do our swap only if though that the current location is not the correct location for the value. So in SelectionSort we assume or we hope that the value is in the right place already, but if it's not in the right place, then we swap wherever the value is to wherever it should be. So we swap the number that's in the correct location out, and we swap our correct value into the correct location. So it is just that, keep finding the minimum value and then keep swapping that minimum value with the correct location, assuming that the correct location isn't this location. So we've got the if statement for checking, finding the minimum value in the middle of the loops, and then in the outside of the first for loop, we do the swap if we need to. So as with them all, if you read through the code, check if it makes sense to you, follow the logic of it, even try an implementation, step through an array of value 2, step through an array of value 4, and step through an array of value 8, and see if that makes sense. So unlike bubble sort, where we sort from the largest to the smallest, with SelectionSort, we're sorting from the smallest to the largest. Thanks very much. We'll see you on the next episode.